Hi everyone, welcome to this quick explanation of right triangles using SOHCAHTOA. If you've ever been confused about which trigonometric function to use when it comes to right triangles using the trigonometric ratios, sine, cosine, or tangent, then you are in the right place. So let's get into it. What is a right triangle? A right triangle is a triangle with a 90-degree angle. This side facing the 90-degree angle is called the hypotenuse, and it happens to be the longest side of any right triangle. The other two sides, this one and this one, are called the legs. These two acute angles, they add up to 90 degrees. Sometimes this acute angle and this acute angle are the same, such as, for example, a right triangle with this 90 degree, of course, and these two angles, each one of them is equal to 45 degrees. The hypotenuse, as we said, is the longest side of the right triangle and is always the side opposite to the 90-degree angle. What is SOHCAHTOA? SOHCAHTOA is just a memory aid to help you remember the trigonometric ratios that we apply when we are dealing with a right triangle. Let's see some of the most important properties of a right triangle. A right triangle has one angle equal to 90 degrees. The side opposite to the right angle is called the hypotenuse, and it's also the longest side. The other two sides are called legs of the triangle. The famous Pythagorean theorem we apply also to a right triangle and help us find the sides of a right triangle. The Pythagorean theorem says that the hypotenuse to the power of 2 is equal to the square of the other two sides added. If we add the other two sides, each one of them to the power of 2 is equal to the hypotenuse to the power of 2. The two acute angles always add up to 90 degrees. Remember that any triangle, it doesn't matter if it's a right triangle, a scalene, isosceles, or equilateral, always the internal angles, these angles, they always add up to 180 degrees. So what does SOHCAHTOA stand for? The S stands for sine, the O stands for opposite side, the H stands for the hypotenuse, the C stands for cosine, the A stands for adjacent side, the H, as we said, stands for the hypotenuse, the T stands for tangent, the O again is opposite side, and the A is adjacent side. And remember, we apply SOHCAHTOA whenever we are dealing with a right triangle. Now, what are the formulas for sine, cosine, and tangent when we are dealing with a right triangle? Sine of the angle, let's say you are given this angle, is equal to the opposite side over the hypotenuse. The cosine of the angle is equal to the adjacent side over the hypotenuse. The tangent of an angle is equal to the opposite side over the adjacent side. Now remember, it's very important which acute angle you are dealing with, because let's say in a given problem you are dealing with a right triangle, and as part of the information that is being given to you in the exercise or in any given problem, they are giving you this angle. So if you have this angle, the opposite side will be this one, the one facing the acute angle. If you look at this right triangle here, you are given this acute angle, then this side is not anymore the opposite. The opposite would be this one, which is facing this acute angle. The hypotenuse is always, as we know, the longest side of the right triangle, and is always the side facing the right angle. The side left becomes the adjacent. In this case, this is the adjacent side, and in this case, this is the adjacent side. So remember, if you have this acute angle, if you look at the side that is opposite to this acute angle, of course, this is the opposite side. But in this case, this is the angle that it's being given to you. So the side facing this acute angle becomes the opposite. As you can see, these two right triangles that are similar, the opposite is this side, but in this case, the opposite is this side. In this case, this is the adjacent, and in this case, the adjacent side would be this one. Okay, so let's try to do some exercises regarding SOHCAHTOA and apply to right triangles to try to find sides or angles of a right triangle. Now remember, we have SOHCAHTOA. SOHCAHTOA. And remember that this is the right triangle and these are the acute angles. Now let's say you are being given the hypotenuse and this angle, 30 degree, and we need to find the adjacent side of this right triangle. So which one you think we should use here? We have the hypotenuse and we have the angle. Should we use this one? Sine opposite hypotenuse? We have the hypotenuse, but we don't have the opposite. Should we use this one? Cosine, we're looking for the adjacent, which is A, and we have the hypotenuse. And what is the formula for K? C-A-H. It's cosine of the angle, which is 30, is equal to adjacent side over the hypotenuse. So cosine of 30 is equal to the adjacent side, which is unknown, divided by 10. So once we do this operation here, we have adjacent equal to 10 multiplied cosine 30. Now this, you can use your calculator to find cosine 30, and this way when you find cosine 30 using your calculator, multiply by 10 and we find this side, the adjacent side. Okay, so let's do another example. And remember, SOHCAHTOA. Always try to label your right triangle to make it easier while you are doing your homework or your assignment. So let's say we are given, in this example, we are given this angle, 20 degree, and we are given this side, 15, and we need to find this side. So which one you think we should use? This one, or this one, or this one? We have the opposite sides, as we know, because it's the one facing the acute angle. So we have the opposite But this one involved the hypotenuse, which we don't have, so we would have two unknowns. Let's see this one. This one also involved the hypotenuse, which we don't have. Now let's see this one. Tangent of the angle is opposite, is equal to opposite, which we have, over the adjacent, which we are looking for, right? So remember, tangent of the angle, let's call this angle theta, is equal to opposite over adjacent side, right? So let's write tangent 20 is equal to the opposite side, which is 15, divided by x, which is the adjacent side, right? So once you do this operation, we end up with x equal 15 divided by tangent of the angle, tangent 20. For this one, the tangent 20, you can use your calculator, and this way, once you have this number, 15 divided by this number, we can find this side. Now let's do another exercise. Now in this one, in this exercise, we need to find this angle here, and we are being given the hypotenuse, that's 15, and we are being given also this side, the opposite side, let's say this is 7, and we need to find this angle. Now again, SOHCAHTOA. Which one you think we can apply here? We have the hypotenuse and we have the adjacent, so definitely we can apply this one, right? Cosine of the angle is equal, no, sorry, not this one, sorry. We have the hypotenuse and the opposite side, so this is the one that we need to apply, right? Sine of the angle is equal opposite over the hypotenuse, which is equal 15. Now, one thing that we didn't mention before when we were talking about the properties of right triangles and trigonometric ratios, whenever you have a trigonometric expression like sine, cosine of an angle, or tangent of an angle, and you need to find the angle, you need to do what is called the inverse of the trigonometric expression. So for example, sine of the angle would be sine, would be equal to sine to the power of -1. The same for tangent of an angle would be, the angle would be tangent to the power of -1. So in this case we need the angle, right? So the angle is equal to sine to the power of -1 of 7 divided by 15. And again, you can do this using your calculator to find t. So that's it. You just learned how to solve right triangles using SOHCAHTOA. Keep practicing. The more you practice, the more efficient you become in this type of problem. This is a topic that is part of geometry in the 10th grade in high school. I hope this video will be helpful, helping you with your homework. And see you next time. Thank you for watching.